In this video, we're gonna talk about surfaces and how we can graph simple surfaces like plane or cylinder in a space. Let me start by defining a surface. Definition: a surface is an equation. So an equation in x, y, and z represents a surface in a space. Okay, so let me give you one small note. For plane, for R2, okay, when we have a set of all ordered pairs, we're going to use R2. R2 is the Cartesian product of R and R, which is the set of all ordered pairs such that X and Y are in R. This notation R2 shows all the points in XY plane that we are familiar with. But for a space, we are going to use R3, which is R cross R cross R, the Cartesian product of three R's, real numbers. The set of all ordered triples such that X, Y, and Z are real numbers. Okay? So this is space. X-axis, Y-axis, and then Z-axis. Okay, so we're gonna show the plane by R2, and if you're talking about the space, we're gonna use R3. Okay, let me give you an example of a surface. Look at y equals to 5. What is that? Y equals to 5 is the set of all the points where the second coordinate is equal to 5. Okay, so x is free. X can be any real number, but y is 5 and z is also free. Z is also all real numbers in R3. So if I want to graph it, I'm gonna say that this is x-axis, this is y-axis, and then this is z-axis. Okay, so the set of all the points 1, 2, 3, 4, 5 with y equals to 5, but x and y can be, x and z can be any numbers, would be a plane exactly at y equals to 5. Okay, so this would be like x z plane, but 5 units to the right. Okay, let me graph the shape for you. So y equals to 5. Okay, so this is y equals to 5. Actually, 1, 2, 3, 4, 5. This is the y-axis. Toward me is x-axis, and then this is positive z-axis. So this is a plane with y equals to 5. Let's look at another example. Okay. Example: x equals to y in R3. What is that? Let me first show it to you. X equal to y in R2. You know that x in R2 we have x, y, and x equals to y would be just the simple line, this, y equals to x. What do you think about in R3? Okay, so in R3, z is free. X and y are equal to each other, but z is free. Okay, so let me try to graph it. Just think for a second. X, Y, and Z. Okay, so all the points where the first and the second coordinate are equal to each other and the third coordinate is free. X equals to Y. So this is a vertical plane bisecting X, Z, and Y, Z plane, right? Let me move this one so you don't confuse. Okay, let me graph it for you. See, y equals to, I'm gonna edit this one, y equals to x. You see, that's this plane. Z is free, so Z can be anything. But x and y, so this is the set of all the points where x and y are equal to each other, but Z is free. So this is that. Let me give you another example. Example, what does this equation x squared plus y squared equals to 4 represent in R2? Okay. How about in R3? Think about this. The answer for the first one. In R2, you know that it's a circle. It's a circle at the origin with radius 2. Is that right? Okay, so if I want to graph it, x-axis, y-axis, and it's a circle at the origin with radius 2. Okay, but how about the same thing but in R3? So in R3 we have all the points have triples, they have 3 coordinates, but in this equation this the third coordinate is free. Okay, so let me write a better note. So this is question 1. Question 2 is x squared plus y squared equals to 4 in R3. Okay. The answer for this, x, y, and z. So I have a circle of radius 2 in here, but since z is free, I can move up or down. Okay, so as you see, this is a cylinder. It's a cylinder with radius 2 at the origin, right? How about the third question? Question 3. How about this equation, x squared plus y squared equals to 4 and z equals to -1. Now z is not free. Okay, we have the set of all the points with the first and second coordinate following this rule, and the third coordinate is equal to -1. What do you think? I'm gonna graph the axis and I'm gonna give you some time to think. X, and then y, and then z. Okay, since z is equal to -1, everything is gonna happen at the plane z equals to -1, right? But the first and second coordinate is gonna follow this, so it would be a circle of radius 2 at z equals to, let me graph it with another color. With the radius 2, but at -1. Okay, so I'm gonna be down here at z equals to -1, but I have a circle of radius 2. Okay, so let me just show you to the cylinder. That was from previous example. I'm gonna have x squared, y squared plus x squared, and it's equal to 4. Okay, that's a cylinder. Z is free, so I get this cylinder. Very good. That moves along the z-axis. Let me ask you one more question. This is question 4. What is this one? How about x squared plus z squared equals to 4? What do you think? I'm gonna graph the axis and I'm gonna give you some time to think. So, I have x-axis, I have y-axis, then I have z-axis. Now you see, x and z is equal to 4, but y is free this time. Now this is a cylinder along y-axis with the radius 2. So I need to have a circle of radius 2 in xz plane, but since y is free, it's gonna move along the y-axis like this. Okay, let me graph it for you. This is, let me just change the y to z. Now you see, it's the cylinder that moves along the y-axis from -infinity to +infinity.